another episode of 3-minute videos from Nathaniel. Today will be my birthday's eve, which will be on the 20th. And on the 20th is my birthday, and it's my 12th birthday this year. And by the way, from the best, it said, here is the cat which made the video 99 times better. Say hello, Coco. My cat doesn't like being carried, so I think I'll just put her down. Okay, so let's start with discussing 12 facts about the number 12. So 12 is a recurring motif in this video. Let's start by introducing something. You know, our system focuses mainly on 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But what if our system wants to focus mainly on 12? This has been a topic of many mathematicians throughout the decades, and 12 has been a superior system because it has more factors than 10. Without further ado, this base is actually called dozenal, and it needs 2 extra digits. Let's write down the numbers from 1 to 12 in dozenal. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we need 2 extra digits, so we call them dec and L, and do is our 12. So that's it. We now have all the numbers from 1 to 12 in dozenal, which is called do. And let's write our first point about dozenal here. Our second one is more on a particle physics-y kind of thing. You know about the standard model? There's a standard model which has basically all the particles in it. There are 12 fermions in the standard model. Let me just write them down for you. So there's the up and down quarks, top, bottom, strange, charm. And there's the electron, the muon, and the tau, and the neutrino versions of each. So we now have 12 fermions. Now number 3 is more of something that isn't specific to 12, but it actually crops up when you're dealing with really large numbers. So number 3 is basically 12 is a superior highly composite number. Superior highly composite number isn't a very interesting topic, so let's just say that it's a highly composite number, meaning that it basically has more factors than any number below it. So the first few highly composite numbers are 1, 2, 4, 6, 12, and the superior highly composite numbers are 1, 2, 6, and 12. Notice the big gap here. 4 is not a superior highly composite number. The next highly composite numbers are the first 5 multiples of 12, 12, 24, 36, 48, 60, and the next superior highly composite number is just 60. Right, so let's move on. Let's see what we have here. It has to do with powers of 2. So, powers of 2. You know 4, this is our 4th point, coincidentally it relates to 4. 4 to the power of 12 is coincidentally equal to 8 to the power of 8. And speaking of powers of 2, I would like to present something. 6 pages of non-stop digits in the decimal expansion of 4096 to the power of 4096. My favorite power of 2. This looks like a phone book, right? Well, it isn't. And if you think this is a phone book, well, too bad for you, it's just a book of decimal expansion. Now, it says that our next point here is that number 5 is, you know, the sum of positive integers, they are the triangular numbers. Now, what's the infinitive triangular number? Well, it will be surprising. Ramanujan got this, and this result is surprising. But it won't be if you're Ramanujan. Yep, right, I gave this brain teaser to some other people before. So someone gives you $1, then the same person gives you $2 the next day, then $3, then $4, and how many dollars will you get if you live for forever and that same scammer lived on forever? Well, he's trying to rob you 1/12 of $1, or around 8.3 cents. Now, it's a pronic number, meaning that it's one number multiplied by another. We got this real quick. Now, 7 is, wait, actually 6 is also a pronic number, it's also 2 times 3. Now 0.7, it is a Pell number, meaning that 2 times this number, which is 12 squared, plus 1 equals to 289, which is also a square, 17 squared. And coincidentally, 17 is my favorite 2-digit prime. What's yours? Now the next one is particularly interesting. Since we talked about decimal, let's concentrate on other bases like hexadecimal. So in hexadecimal, you have 16 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you have A, B, C, D, E, F, and then you have 10. Now the 12th digit is C in many other bases. But somebody out there denies something called algam, where this 12th digit is represented by a small gamma, and it's called Z. I hope you like it. Okay, our next point is that it is the kissing number in 3 dimensions. What does that mean? If you put 12 spheres around a sphere of the same size, that is the maximum number. Unfortunately, when Isaac Newton was discovering this, a lot of mathematicians out there were debating that the kissing number was actually 13, but it was proved that it was 12 a few hundred years later. Now, it is... What's interesting about here? Okay, this next one relates to the number of polyhedra. So 12 actually has a prominence in polyhedra. You know the platonic solids? 12 is a number of edges in a cube and an octahedron. Try counting them up for yourself. Sorry about drawing polyhedra. And the number of faces on a dodecahedron, as you might guess. And the number of vertices on an icosahedron. And twice the number of edges on the tetrahedron. So you see, 12 crops up frequently when you're talking about the platonics. Okay, so this next point is a bit on a special property here. So a perfect number is one which has the same number, which when you sum up all the divisors, you have that number itself. Now 12 is what's called a sublime number. So you have 1, 2, 3, 4, 6, 12. The number of divisors is a perfect number, and you sum them up, you have another perfect number. Well, this is called a sublime number, and it's really sublime, and in fact the next sublime number is actually 76 digits long. Well, that's a really sublime property, is it? Now, let's move on. If there are any odd perfect numbers, which we talk about perfect numbers, so far nobody has found any odd perfect numbers. But an odd perfect number is of the form 12k plus 1, where k is an integer. It must have at least 12 distinct prime factors. So how many times has 12 occurred in here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, our point 9. So you're going to write that down. Actually, it's the kissing number. So 12 is come out here. It comes out 4 times in here. And it comes out once in here. And in our last point, it comes out twice. So let's count the number of times 12 comes out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 times the 12 comes up here. And how many 12s does it make? So 15 times 12 equals to 180. So we have 15 mentions of 12, which add up to 180, which is coincidentally 180 times 2 equals to 360, which is the number of turn and degrees in full turn, and 180 is the number of degrees in a half turn. So that's it. I hope you like 12 facts about the number 12. And by the way, like and subscribe to my channel and see other MAT and other strange maths videos I will post about certain numbers or certain number systems or certain anything maths or music or science. You're welcome to join my channel. Goodbye.